These are clones. A clone is a living thing genetically identical to another living thing. You and I are one of a kind. But what if you were not? What if we could make a duplicate of you, genetically exact? Should we? People fear genetically engineered clones. Would an individual still be individual? See, it may be possible to use the same techniques that we'd use to clone a new person to instead rebuild or repair organs or even cure genetic diseases. The things we're talking about are microscopic, but the possibilities are far-reaching. Should we pursue cloning? Well, we're going to look at the science, and then we can each decide for ourselves. The eyes of night. These are clones. Each of these grapevines is just like all the other vines. They were all grown from cuttings of the same plant. In fact, our word clone comes from the Greek word for twig. See, clones are not that unusual. They're offspring produced without sex. These two plants are genetically identical and asexually reproduced. They both came from a single parent, and they both have the same DNA. Now, when these individuals were created, there was no help from flowers or the birds and the bees. No pollen was exchanged. There was no sex.
I'm pregnant.
I'm going to be a...
You're not the father.
What? Who is? Oh, kill him.
I am the father.
But you are the mother.
I am the mother and the father. Listen, like the grapevine, I have discovered the beauty of asexual reproduction.
I didn't know grapes could be so nasty.
You idiot. I have cloned myself.
¿Por qué?
So the baby will be all of me and none of you.
And this baby, it will be just like you?
Not necessarily. She will look like me, but she might not be like me.
In that case, tell her to call me in about 18 years.
Get out! Get out of my sight! You make me sick!
Ah, humans. Now, we can't reproduce asexually, just cloning ourselves like grapevines. Oh, no. We have to have sex. That couple has started on the process of sexual reproduction, where half of the genetic information comes from the woman and half comes from the man. But we're talking about cloning, asexual reproduction, where all of the DNA comes from a single parent. Now, all of the cells in your body that are not sperms or eggs are called somatic cells. And almost every somatic cell carries a complete copy of an organism's DNA. So to clone an animal like Dolly the sheep, scientists start with an egg. Then using the tiniest of glass pipettes, they pull the nucleus of that egg out. And then they get the DNA from another somatic cell. Or they take a whole cell, DNA and all, and poke it back into that egg. Now this is called somatic cell nuclear transfer. It's cloning. Then scientists give this egg a tiny jolt of electricity, or just the right chemical mix to get it to start growing, to start dividing. Then they put it back into the womb of a sheep, and if nothing goes wrong in a few months, you get a lamb. Dolly the sheep was born on the 277th try. That's after 276 failures. Cloning is a tricky business. Now, if we have this much trouble with farm animals, are we really ready to try it with humans?
No.
Now it's time for Opinions Now with your host, Chris David.
Tonight, what would human clones be like? Biologist Dr. Albee, what do you think?
It's very difficult to say.
Guess! Now!
As a scientist, I don't really guess
Holy
about
cow,
anything.
who booked this guy? Genetics expert Dr. Sandra Davis, what would human clones be like?
Well, we're not really sure.
Come on, doctor!
Well, if you'd like me to speculate.
Yes! Speculate! Wildly! Now!
I won't speculate wildly, but a reasoned hypothesis is that we could all end up with that loss of a certain spark that makes us individuals.
You're saying that we would all be sheep-headed zombies?
Not necessarily.
Jack-booted stormtroopers engineered to be perfect soldiers as part of the government's plan to make us all prisoners to its will?
Excuse me, I didn't get to make my comment.
Yeah, nobody cares, biologist boy.
But as a scientist, I thought you'd want my expert opinion.
I'm out of here.
Proteins in sea squirts and human embryos are the same proteins that are causing embryonic development.
So they're the same genes as people.
Right. A human starts as one cell, a sea squirt starts as one cell. But it's the way the genes are turned on and off that decides what it's going to finally look like.
So you use these animals to study cloning.
Right. We use them to study how genes are turned on and off during development. So most of your cells right now, the DNA is off, which means it's not making protein. They might have been used before to make an ear, but now that you have an ear, those cells are only used for specific functions.
But when you're being born, when you're a single cell,
The egg starts as a single cell, so that first single cell has to somehow turn on and off all the genes necessary to make that adult organism. Now, how does that happen? The egg actually puts proteins in the cytoplasm that tells the nucleus where certain things are supposed to be made. So those transcription factors, proteins...
That's what you call those proteins?
Proteins, yes. Transcription factors will go into the nucleus at certain times and then turn certain genes on and off. And each animal has the same set of genes turning things on and off, but it's how and when you turn different genes on and off that makes different adults. What you do in cloning is you take this nucleus out of there and you put in a nucleus from an adult, and that's the difficult part, is getting that nucleus from an adult to go through this whole process of making an embryo. The reason reproductive cloning doesn't work very well is because you have to take the old nucleus and you have to make it think that it's a young nucleus. You have to make it think it's a nucleus that's in an egg. This is a difficult process, and these nuclei are old nuclei, so a nucleus in your, say, skin might have lived so far for a number of years, maybe 40-some years, and so you have to take that old nucleus and try to make it young again, and we're not sure how to do that. That's one of the most difficult things about reproductive cloning. It's a very low success rate, maybe 1% to 2%, if you try to clone yourself.
Is that why Dolly was such a big deal?
Well, Dolly was a big deal because she was cloned. She also died at the age of 7, which is about half as old as a regular sheep would live. And so there's some idea that the nucleus was too old, and that's why she died at a premature age, is because even though the nucleus was tricked into thinking it was young again, it really wasn't that young again, and so she died.
So what's the controversy then about reproductive cloning?
Well, I think there's really two controversies. The first controversy is, where do you get the eggs? So people are worried that there will be some sort of black market for human eggs, that young girls who otherwise might not give their eggs away will be induced to do that for money. So the source, where's the source of eggs, is one problem. And then the second one, I think, is the embryos themselves. When you understand human development, you'll understand that you cannot make a baby from those embryos unless they're implanted into a uterus. So as long as the embryo is kept in culture and kept outside of the mother, it will not make another human being.
Is there a place to draw the line?
For the Society for Developmental Biology, as scientists, we've come up with the rule that we're for therapeutic cloning and not for reproductive cloning.
When it comes to the technology of cloning, the train has pretty much left the station. See, once we perform somatic cell nuclear transfer, we get an embryo, not a fetus, an embryo, cells that are dividing. Now, there's two choices as to how we use that embryo. We can go this way. It's what we call reproductive cloning. Make a new cow or a sheep, or theoretically, even a person. But we don't have to go that way. if we don't implant the embryo into a womb, just let it grow, we can instead go this way. And this is therapeutic cloning. And the cells grow and divide as what we call stem cells. Now, stem cells can become any type of cell. Now, here's the thing. The procedure for reproductive cloning and therapeutic cloning is exactly the same up to this point. Up to this point, this fork in the road. If we go this way, we would get new people. If we go this way, we would get new cells. Which way do you want to go? Bill, if cloning is so risky and dangerous, why bother?
Well, Bill, if we were to perform a somatic cell nuclear transfer and fuse it so that it started to grow, we'd get an embryo.
We don't get a person.
No, an embryo, a ball of cells that's growing and dividing.
So we couldn't be talking like this.
No, this is an old TV trick. At 5 days along, an embryo has about 200 cells, and they're undifferentiated.
Undifferentiated?
Yes, they haven't started to become all the different cells of your body, like your skin cells, your bone cells, and your brain cells. They're stem cells, and they have astonishing promise.
But if you had to choose between, say, me and a bunch of stem cells, which one would you pick?
Okay, well, here's the fun stuff.
So these are colonies of stem cells.
Right, these are human embryonic stem cells. Each one of these colonies derived from one single cell.
One of these back here?
That's right. That has divided and divided and divided and divided, eventually forming now a few thousand cells in a free-floating cluster, so that we have millions and millions of cells, all exactly the same. And then the next step is to change them first into brain, and then into a subtype of brain that we'd like for repair. So this is the center of one of those large clusters that is now stuck down, and as we move away, you can see very small little cells that all look the same, but then as we move further away, now we start to see them differentiate into these long, mature cells with long processes.
So what do we do with these cells?
Spin them down so as to concentrate them and squirt them into a spinal cord injury in a rat. So here's an animal that received an injury with no transplant. So this animal has not been transplanted, and you can see that he's not standing and just sort of drags his hind limbs around without any coordinated locomotion front to back.
Can't move his back legs.
Very little. It's not a complete injury. This models human spinal cord injuries that are the most common type of them, those sustained by like a car accident or a diving accident, sporting. It's called a contusion injury. So that's what we're trying to treat. It's a pretty severe injury.
So you injected this rat with the human embryonic stem cells.
That's right, that we first tricked to become brain committed and then to a subtype of brain that we know to support repair. Let me just show you what that looks like. This is a nice shot here because we can see that the legs are moving in a coordinated fashion, side to side. So it's not only a matter of controlling one side of his body, he can actually control both. And the tail is up, so he's got full control of his back muscles. And one thing you can't see in this video is that these animals regained control of bladder and bowel function earlier than the non-transplanted animals. That's the #1 concern of people in wheelchairs. But if we take an animal with a similar injury, only 2 weeks after transplant, you can see he's supporting his weight and standing, and you can see he actually takes some steps. Yeah, he's doing well.
So what's happening inside the rats?
Well, what's happening is that the cells that we put in are integrating into the spinal cord, and the spinal cord itself is growing through the injury in the transplant site, up above the injury site. So it's anatomical evidence for repair.
So how long did this take?
This took about 10 weeks.
So this works?
It looks like it's working. I'd say this is strong preliminary evidence that human embryonic stem cells have a real beneficial future.
Would you say you're in favor of therapeutic cloning?
Absolutely. I think therapeutic cloning could be to brain trauma and disease treatment what the jet engine was to the airline industry.
Good evening. My guest is Congressman Peter Newton. Congressman, what do you think about the controversial procedure of using embryonic stem cells in research?
I have said many times that we really need to study the subject more and not rush into a decision.
But many people say that a tiny embryo, even one consisting of just a few undifferentiated cells, should be given full human dignity and worth.
Well, absolutely. It is outrageous what is being done. We need to stop this stem cell madness now.
However, some studies show that up to half of all people could benefit from stem cell research.
Is that the half that votes? Because if so, I say let's stop this foolishness and fully fund this research right now.
I think pudding tastes good.
You know, I have always supported pudding, even when it was politically unpopular to do so.
I give up.
Is it okay to take a woman's egg and use it to grow stem cells? Is that okay?
No, not to me.
I don't think so. I think everything should be able to live.
At that stage of its development, it doesn't really have, I mean, it's just kind of like any other cell. I mean, it has the potential to grow into a human, but it's not necessarily human.
I would say yes. It certainly is okay, because after all, I mean, if she doesn't give up the egg, and if it's not fertilized, she's going to expel it anyhow.
Look at a woman, how many eggs she passes a year. You know, it's an egg. You know, you got a lot of them. I'm sure you could start one.
Here in the United States, the debate about embryonic stem cell research rages on. It is a debate about life. On one side, shouldn't we use this technology that could improve the lives of millions of people who are already here? People have been struck with disease or injury. On the other side, the question is, when does life begin? Some believe life begins the moment the first cell divides. So if the Petri dish holds living cells, is it morally acceptable to redirect those cells and transform them into something they wouldn't otherwise become? Then there are concerns about the industrialization of life. Should human embryos be declared inventions that you could patent? That's what we have to figure out. But how do we pursue a thoughtful discussion on stem cell research? Can we find a way to make our trains meet?
Bioethicist, bioethicist, bioethicist!
We're all ethics experts because we all have to make decisions about what's right and wrong. And it's not fair to ask me or any one person, what's the right place to draw the line? It's a question that we all have to answer collectively, socially, because it's an issue of social policy. We have to decide at what point do we think it's acceptable to use human embryos and potentially past human embryos. And we have to answer, is an embryo, a human embryo, in terms of its moral status, more like the cells you can scrape out of your cheek or more like the person who's sitting before you today, you or I? And I think it's in between. And the question is, I think not whether there's some moral status of human embryos, because I think most people think there is some moral status, but it's not full human being personhood status, and it's not mere tissue. It's in between those two. And the question is, what's the moral benefit we can get from doing it? It's really a balancing. There's a concrete reason that it's worth doing research on human embryos that causes their destruction. There's real cost to doing this research, but the benefit is great enough to outweigh those costs.
What do you think would be the tipping point for therapeutic cloning moral rethinking?
The first kind of therapeutic benefit will be not for building new hearts. That's too complicated. It will be for taking cells and turning them on in ways that will treat disease like diabetes. I think it'll be the likely first case. How many tens of millions of people in the US who have diabetes of some form or another, from kids through elder adults? It would have a huge impact on people's lives and health. And so then you say, wow, there's a real benefit to a lot of people, not just a few people, a lot of people. How can we hold them hostage, hold their welfare, hold their health hostage, because we think that these tiny cluster of cells have somehow more moral status than they do? That's the argument.
If we're going to pass laws to regulate cloning, right now, if I understand it, it's illegal, any kind of cloning.
No, in the US there's actually no law against cloning. That's what's sort of amazing about the current stalemate in Congress. The House of Representatives has passed 2 cloning bans in the last 2 sessions, but the Senate has not acted either time, and so we have no law. And so it's actually perfectly permissible to do cloning in the U.S. now.
So what's your strong feeling? What's your view? And if I understand this, we're talking about where is this line to be drawn?
I think we ought to allow human embryos, certainly that are left over from reproductive purposes, that are not going to be used for reproduction anymore, that will be discarded anyway, to be used in stem cell research with federal money. So that would be an expansion of what the current policy allows.
We've come to a threshold in human history. Stem cells could improve or save millions of lives. So I'm in favor of therapeutic cloning. Growing embryos just for their cells is unnatural, but so is my appendectomy and polio vaccines. Now this is different because we're talking about embryos. But we each have to decide, is a microscopic ball of undifferentiated cells, whether fertilized or clones, a person? See, there are people and institutes full of people called bioethicists, and they study the ethics of life. But when it comes time to vote, what's the difference between them and you and me? Nothing! That's why you gotta think about cloning. You gotta think about stem cell research so that we can all make good decisions as citizens and for our society. Thank you.